Hi all, welcome to Graphics Desk.
Now in this video we'll talk about how to draw orthographic projections of the given object. So what we have here is object is basically a cube looking object which has 60 mm height, 60 mm width and same 60 mm as length. Now what we have to use here is that the first angle method of projection. What we have to draw is front view. It's in fact is a sectional view along BB plane, which is highlighted here as BB plane, and top view and right hand side view. Now as the height, width and length of the object is 60 mm, which essentially all the three views will have 60 mm square, and any geometry within it would be the respective view. So this BB plane is basically cutting these two circles exactly on their diameter, and in the front view we will get these are cut through their diameter. So as we have to use first angle method of projection, front view, top view and right hand side view, that means this is where your front view will be, this is where your right hand side view will be, and this is where your top view will come. So let me split the page into four different parts, and we'll use it for drawing those views in the respective section. Right, so to start with the front view, as I said that this will be a square, all the views will be square. So we have to mark this line as 60 mm first, and then which is the width of the object, and this is also 60 mm, that is height of the object. So we'll have a square over here. Let's draw that first. Now we have completed the square and all our geometry, our view would be contained within this square. Now I've intentionally drawn these lines as faint lines here. The reason for that is we are yet to draw the curved part of the geometry, which is the circle here. So right now this is faint and it has to be removed once we draw the circle, quarter circle over here. So let's look at the center of this thing first, which is 35 mm from the base of the object, and which essentially 25 mm from the top, because 60 minus 35, that's 25. So it is 25 mm from the top and 25 mm from the right hand side face of it. So let me measure that. So this is the center, which is center for this hole and also for this arc. Now this arc, which is a quarter circle, is basically radius 25, and this circle is 515, that means diameter 15. So this center is we have located, and I've extended the lines till here because this circle and this circle lies on the same vertical line, so as this circle and this circle, center of these lies on the same horizontal line. So essentially this is the center line or center axis for this particular hole, and this is the center line or center axis for this particular hole. So let's draw this arc first, and then we'll go to the side part of it and the base part of it. Of course, this part would be a solid part because this is visible and it is not affected by the section. Now, what we have here is that side wall, I would say, is 12 mm in thickness, so as the basis. So let's mark 12 mm from this point vertically up, and 12 mm inside from this particular face. So what we have here is two lines intersecting at this point, where this line is basically represents this particular face and this line represents this particular face. Now again, these things would be solid because they are cut through, and we need to locate the hole which is also bisected by this BB plane on its diameter. So the diameter of it is 15 mm, which means from the center point it is 7.5 mm on this side, 7.5 mm on this side. So as for this hole, it is 7.5 mm vertically up, 7.5 mm vertically down. So let's locate those points and let's draw the edges of the hole which would be visible in the sectional front view. Now all of these lines which you are seeing here, this one, this and this, also this one, would be solid lines. So this line basically will, until this point, would be solid, so as this line until this point would be solid. This is not part of the object anyway, so we'll take that out. Now this is our sectional front view. The only remaining part is this hole which is diameter 15 mm, and we have already located its center. Let's draw the circle with radius as 7.5 mm. So this is the circle with diameter as 15. Now let's quickly locate the center lines and the hash area. We have to hash out this one, and this one. This will not be hashed because it is part of the hole, which now left out as a semi-hole, I would say, or section of the hole. So as this one. So this will not be hashed out, this will not be hashed out, but rest of the part would be hashed out. So let me mark the center lines and hash area. Okay, so this is what we have, the sectional front view, where section is taken along the BB plane. Now as this object is made out of a cube, or I would say has a boundary of cube, all the views, top view and right hand side view, will have a similar view. But it will slightly be different in terms of its orientation. Okay, so let's draw the top view now, and then we'll go to RHS view. So I'm carrying the projections from this point onto the area where we want to draw the top view, and then we'll see how to measure distances from there. So these are the projections taken from the top view. Again, we have the length as 60 mm, so it is 60 mm. Let me mark the side of it, which will be solid. This face would also be solid, 60 mm. And as I said, that it is again a square or geometry within the square. So let me complete the square first, and then we'll see what all details that we'll have to enter in it. So this is our square, and our entire geometry would lie within it. Now in the top view, what we have visible is this face is visible, which is essentially this one. This particular part of the geometry which is visible, which will be here with the width of 12 mm, which is already given, and this is this particular face. So this is already marked or available from the projection. You have to mark 12 mm in this direction, which will give us this shape of representing this particular face, and then a hole at this point, which is 25 mm from here, or you can measure 35 mm from the top face. That means from this face, this particular center is 35 mm. So let's mark that. So this one is now the center for this particular arc and this particular hole, whereas this line is representing this entire face, which I've already drawn in the front view. But here in the top view, it will be represented as line. So what part of it would be solid is that this particular line until this point, this particular line until this point, and there will be an arc of 25 mm here. This will be solid and this will be solid. So this is our top view, except we have to draw one circle here, and the circle on this face would be visible as dotted line. Now we are talking about dotted line here because this is not a section and no part of the hole will be visible, hence it will be dotted line. So a dotted line here and here representing a hole in this wall, and a dotted line here and here which will be representing this particular hole. So let me draw that. Okay, so now this completes our our top view. This is how it will look like. So we have drawn all the lines that are visible and dotted. Let me draw the center line very quickly. Now, one thing to note in the front view and top view both is that this center line and this center line, even though they are part of the same line, they are not continuous. The reason for that is this circle is basically a quarter circle, and this is a full circle, has this as center. So this particular line should slightly extend this particular circle and should slightly extend this particular quarter circle. Same goes with here. Now this particular hole has the same center line, but this need not to be in the continuation. It should slightly extend to this line, so as slightly extending this line on the other side. Same goes here also. So please don't draw a continuous line here, because it's not a continuous hole. These are two different center lines, so you should show the gap or a break between. Now with that we have completed our top view. The next and the last is the right hand side view. So for that what we'll do is, this is where your right hand side view will come. Now for that what we'll do is, we'll carry the projections from the left and right, and this time around I'll use a protractor to or rounder, I would say, to carry the projections. In my previous video I have drawn a line 45 degree and then carried the projections, but this is yet another method which you can use. So what we have to do is we have to carry these projections up until this point, and this being center, you have to roll all of these projections onto this line, whereas horizontal projections will come from the front view. So let me do that. Okay, we don't have to carry a lot of projections here, only a few. Now we have taken all of these projections on this line. We have to draw vertical lines, and horizontal projections will come from this view. Now this is yet another method which is works the exactly same way as I have shown in my previous video, where you are drawing 45-degree line, and you don't have to use any curves, but the straight line from these points would give you these same exact projections vertically up. Now let me carry these projections and we'll look at the geometry here. So as I mentioned previously, this is more like a cube structure. So this is the boundary of our object. This point, this one, and this one. This is a square, in fact. And what we have available or visible in the right hand side view is this particular face would look like a straight line, which is this one. This particular face would look like a straight, which is here, and this hole is visible, which has this as center, and the same center is for the arc on this side. So let's draw that. Okay, so this is this is how our right hand side view would look like. We have to draw a hole here, and then which is this hole, and again a dotted line representing the hole in this wall, this particular side here, and this hole would be at the bottom. So the diameter of this particular hole is again 15 mm. So I'm measuring 15 mm, 7.5 mm in this, and we'll draw a circle here. Now, as we have already mentioned, that this is more like a cube structure, so all your views are exactly similar, except that you can say that they are turned 90 degrees. This, if you turn 90 degrees, this is what the view is getting. If you turn this further into 90 degrees, this is what your view would get. Now, as you have completed with this diagram, there are only three things that are left. One is that I have to mark the center lines here, I have to name the views, and I have to do the dimensioning. So let me do that real quick, but otherwise we have completed with our geometry. Okay, so this is how your final solution would look like for the given diagram, where we have drawn sectional front view, right hand side view, top view, and using first angle method of projection, we have completed this. Thank you for watching this video. We at Graphics Desk committed to spread the knowledge. Be a part of this journey, share this video, and spread the knowledge. Until next time, bye.